Hi everyone, so for those of you who are doing some last minute revision for CSEC Math Paper 2 on Monday 13th May, take a look at this question that CSEC sneakily brought into this question 9 part A of January 2018 that actually has to do a little bit with add math rather than math, and I'll show you why. It involves the topic surds, and a surd basically is the square root of a number that isn't a perfect square. So part 1, show by calculation that the exact roots of the quadratic equation x squared plus 2x minus 5 is equal to 0 are -1 plus or minus the square root of 6. And this is worth 3 marks. So if we have to show that the exact roots are -1 plus or minus the root of 6, this means that we have to use the quadratic formula to solve this quadratic equation. So I'm just going to write it on the side here. Of course, this is given in the formula sheet. X is equal to minus b plus or minus the square root of b squared minus 4ac all over 2 by a. So let's substitute. A in this case is 1, b is 2, and c is -5. So let's find the roots. So x will be -b, so -2, plus or minus the square root of b squared minus 4 by a by c all over 2 by a. So let's simplify. We have -2 plus or minus, right? So let's work out what's under the square root. 2 squared is 4. Now the minus and the minus here will give a plus, and then if we multiply 4 by 1 by 5, that will be 20, and in the denominator we get 2 by 1 is 2. So if we add 4 and 20 gives 24. Now these are our roots, -2 plus or minus the square root of 24 divided by 2. Now we have to get it to look like this, -1 plus or minus the square root of 6. So this involves breaking up this square root, right? So this is a topic called surds that comes in add math, CSEC add math, all right? So it's very strange that CSEC brought this in a math paper. So let me show you how we're going to break up this square root of 24. So I'll do this on the side here. So to break up the square root of 24 into 2 surds, we need to find 2 factors of 24 where one of the factors is a perfect square. So of course 4 could go into 24. Of course 24 is 4 by 6. So the square root of 24 is the square root of 4 times 6. So there's a rule of surds that says that the square root of a product is the product of the individual square roots. So the square root of 4 by 6 is the square root of 4 times the square root of 6. And of course the square root of 4 being a perfect square, is 2. So we get 2 times the square root of 6. So -2 plus or minus 2 square root of 6 divided by 2. I could divide the entire thing by 2. So basically the 2's cancel here. Of course, this will be 1. 2's cancel here to give 1 again. So we end up with -1 plus or minus the square root of 6, which we will be required to show. Okay. So this is what you needed to do for 3 marks. Of course, again, remember this is actually in add math, not regular CSEC math. So there is a second part to this question. Part 2, hence otherwise, solve the simultaneous equations, right, for 4 marks. 2 plus x is equal to y and xy is equal to 5. So let's label this equation 1 and this is equation 2. So if we substitute equation 1 into equation 2, right, we get x times 2 plus x is equal to 5. And of course, when we expand this, we get the same quadratic equation that we were solving in part 1. X squared plus 2x, bring over the 5, is equal to 0. So we already solved this, remember. We already showed that the roots, the solutions for the equation is -1 plus or minus 6. Okay, so x is equal to, and I'm going to separate it into the two roots, -1 plus square root of 6, or x is equal to -1 minus the square root of 6. Now, we're not done because, of course, this question is 4 marks. We just found the values of x. Now we need to find the values of y. So, from equation 1, y is equal to x plus 2. So, to get y, we will just need to add 2 to each of the answers. So, -1 plus square root of 6 plus 2. So, we add the constants, -1 and 2 will be 1 plus the square root of 6. And then the other value of y, we add 2 to that. -1 minus square root of 6, add 2. So again, -1 plus 2 is 1 minus square root 6. So our values of y, we can actually put them together because one of them is 1 plus square root of 6 and the other one is 1 minus square root of 6. So we can actually state it as 1 plus or minus the square root of 6. And of course, the x values are -1 plus or minus the square root of 6, and this would be the solution to the pair of simultaneous equations.